Hello, everybody. Welcome to our talk on Gloo Edge, Futures and Directions. I'm Scott Weiss, architect at solo.io.
And I'm Shane O'Donnell, software engineer at solo.io.
So in this talk today, we'll be discussing Service Mesh and API Gateway. Specifically, we're going to start by looking at the current landscape and how does it look? How do these two play together? Then we're going to talk a little bit about the future of this partnership and how they can play nicely together. Finally, we'll talk about how this can be expanded to multi-cluster use cases, advanced security features, and more. So now I'm going to hand it over to Shane, who's going to start with Istio.
Thanks, Scott. So yeah, let's start talking about Istio. For those of you who aren't familiar, Istio is an incredibly powerful open source service mesh. It has a ton of useful features around traffic control, exposing metrics and logs, and it can even secure communications between your microservices using mutual TLS. How this works under the hood is that it injects an Envoy proxy as a sidecar next to each microservice inside of your service mesh. We collectively refer to these Envoy proxies as the data plane. This data plane receives its configuration from Istio-D in what we refer to as the control plane. This is phenomenal and really powerful if you're using a single cluster in a single mesh environment. But how do we go bigger? That's where Glomesh comes along. Glomesh is a unified service mesh management plane that we've introduced to help kind of scale beyond one cluster. This lets you go to multi-cluster, multi-mesh environments and get really advanced configuration. We've seen customers starting to use this technology at the scale of 50 to 100 clusters, and in some cases even more than that. But no matter how big you go, you can always configure your enormous environment from this one management centralized place, which is great. Once you've got multi-clusters, you can do some really cool things and add features like global failover routing, as well as inject things like custom WebAssembly filters across all the proxies in your environment. Once you have Glomesh, I'd also note that you get production support for Istio. This is great for inside your service mesh, but how do you handle the ingress and API gateway aspect of your virtual service mesh? And this is where Gloo Edge comes along. Gloo Edge is the API gateway implementation that we have here at solo.io. And it's an incredibly powerful way to harness the Envoy proxy under the hood, but we've built a higher level API on top of Envoy so that it's easier to configure and manage. We've also built some extra features on top of it, including enterprise-grade security and external authentication. We've also added things like data loss prevention and web application firewall, as well as an out-of-the-box implementation for something like rate limiting. We have a lot of experience running Envoy in production right now, and that's what's informed a lot of our decisions when we move forward to our next generation. We've listened to a lot of feedback that our customers have given us, and this is just a handful of them. And we just like to talk about what does their typical environment look like today. So here you've got a single cluster where you're probably using Gloo Edge at the edge to manage your ingress API. This is your API gateway that handles your north-south traffic in and out of the cluster. But then you might also be using an Istio control plane to handle your service mesh, which is your east-west traffic inside the cluster. But when we look at the feature sets of both Gloo Edge and Istio, we'll see there's a lot of overlap here. They both discover services and upstreams to send traffic to. They both configure Envoy proxies. Where they differ is that Gloo Edge provides some edge features and Istio provides some east-west features. But is that really enough to justify having two control planes? We don't think so. So what happens when it's one control plane? Suddenly you can do all of your discovery, all of your Envoy configuration, and your edge traffic and your east-west traffic all in a single control plane. So it's much easier to manage, especially as you start scaling your environment up. Now this gets us to a single cluster and a single control plane. But what happens when you add another cluster? We're running into a similar problem here where even though there's a single control plane on each cluster, when we have two clusters or we go up to 50 clusters, suddenly there's 50 things to manage. And this is where we already have that solution we mentioned earlier, Glomesh. Glomesh can come in and help you manage configuration across all of your clusters in a multi-mesh, multi-cluster environment. We've got this unified API where you can configure things up at the top in your Glomesh management plane. And this config will be propagated out to the control planes in each cluster. And finally, those control planes will translate and apply that configuration to your Envoy proxies, regardless of whether they're Envoy proxy sidecars running in Istio in your service mesh, or if they're an edge API gateway or an ingress running at the edge of your cluster. Let's take an example of how this might look. Say you want to apply a custom WebAssembly filter to a variety of proxies across your environment. With this new architecture, you could just you could configure it once in the Glomesh management plane, and that'll then flow to all of your proxies across your clusters. You've only made the configuration in one place, but this could apply to a dozen clusters and 24 different envoys. So how does all of this work under the hood? I'm going to pass it over to Scott to talk a little bit about the API.
Thanks, Shane. So let's take a look at how this is going to work under the hood. What's the user experience going to be like? What's the API like? And this will give a clearer understanding of what we're actually talking about in concrete terms. So we have an API that we've actually built off of the V2 Ingress API, as some people call it, or now it's being called the Kubernetes Gateway API. This is an official Kubernetes API being developed by some Kubernetes SIG networking, which is designed to be a successor to the original V1 Beta 1 Ingress API, which is very limited in scale and really very basic. And what Kubernetes has attempted to do with this newer API is to support extensibility by multiple vendors, because you see there are a lot of vendors in the space who are talking about Ingress and Gateway. So we are now utilizing this for our new Gateway API, and this will help us demonstrate what's actually possible to do, and how we've extended this API in order to support our multi-cluster and advanced security use cases. So the first piece to know is that the Kubernetes Gateway API provides a new CRD called the Gateway class. And the Gateway class essentially allows gateway providers to ship their own custom settings, which can be applied to a gateway. So in our case, you can see we have a gateway class here, and that gateway class is going to be responsible for managing a set of gateways. And specifically what we're providing here is the name of our controller, which is gateway controller. So our controller knows to process this gateway class. And we're providing a set of parameters, which are specified here in this ingress settings object. And this is custom to us. So different providers will have different parameters. That's why you can see you specify the group and kind of the settings object so that the implementation can provide its own CRD, its own custom configuration to the user as an extension point. And if we look at what our gateway settings actually looks like, here we can provide a set of clusters, which means any gateways which consume this gateway class will be applied to this set of clusters. And we use that as the first building block of our multi-control plane, multi-mesh, multi-cluster management system. So let's take a deeper dive and actually look. Now that we have our gateway class, what does it mean to add a gateway to this class? So you can see right here, we have a gateway object. This is, again, a part of the core Kubernetes API. And what we're showing here is the ability to, okay, so what the gateway does is it defines a set of listeners. And these are the listeners where our routes into our clusters will exist. So you see here, we select the gateway class that this gateway will belong to. That means that this mesh gateway will be distributed to both the management and remote clusters. And now, what are the actual contents of the gateway? The gateway here defines a single listener, listening on port 8080 for HTTP requests. And the actual routing rules that are defined for this listener will be located in an HTTP route. Specifically, it'll be in a set of HTTP routes that are selected according to a label. This is one of the changes that the modifications we've made and are currently working on upstreaming in order to support a self-service model for these gateway resources. And you'll see here any HTTP route, which again, this HTTP route is another core gateway API object. This is not ours, but it provides extension points, which we'll show in a second. So this is what an HTTP route actually looks like. This is where we define the real meat of the routing configuration. So at the top level, each HTTP route defines one or more host names that it's attached to. So when a request comes to that port 8080, an HTTP route will be selected based on the host name that's contained, the host header that's contained in that request. And this requires that each HTTP route is only responsible for a subset of that traffic. Therefore, HTTP routes are high-level object, and we have delegation feature, which allows multiple users to share the configuration of a single HTTP route. But I won't get into that here. I'm just going to show a simplified single instance of an HTTP route object. So here you can see we provide host names, and then we provide a set of routing rules. And the routing rules will match other fields inside of the HTTP request in order to determine where to forward the request to. So you'll see here, we very simply match the prefix, the path prefix of the request, and /product page, and we're selecting the product page service in the book info namespace to forward the request to. One thing to note here is that we also specify the cluster on the request. This is a modification that we've made to the Gateway API that allows us to define these routing rules outside of any particular cluster. So these routing rules can live in a management cluster or control plane cluster, and they can apply to multiple clusters in your data plane. So here you'll see that we're routing to the product page in one cluster, a management cluster, and then we're routing to the detail service in a remote cluster. Another thing to note here is that we can add, there's a field inside of the HTTP route object that, again, is part of the Kubernetes API, but it allows you to define custom filters. And those filters are where you can specify anything from security policy to transformations to observability and monitoring policies. These are all things that are implemented today in the Gloo 1.0 API. And what we've done is we're now using this filters field in order to support the same set of features, which here you have an example of us configuring rate limiting. But there are a number of advanced features that those who are not familiar with Gloo may not be aware of, and we'll get to those in a following slide. One more thing to note is that when we say here that this route can route to both the management cluster and the remote cluster, and we've said here that this gateway will live in the management cluster and the remote cluster, that means that whichever gateway, it doesn't matter which cluster, so this gateway will live in both the management and the remote clusters, and they will both provide these routes so that they'll know how to route to something that's in a different cluster. Let's just continue here. So another example of how we've extended the system. So we just covered how we're able to address policy as well as multi-cluster Kubernetes services. But now there's another feature from, or another domain of features that Gloo supports, which is routing to things other than Kubernetes services. These are things that the control plane like Istio or Envoy itself are not aware of, but we are able to orchestrate the underlying piping in order to enable routing requests to another type of destination rather than a Kubernetes service. So the core Kubernetes API, this new Gateway API, offers a backend ref as an alternative to the service name, which you can see here. The backend ref, just like the settings that or the parameters that we provide on the gateway class, is an arbitrary CRD. So we can decide what actually goes there. And this is now where the binding comes in between the core Kubernetes API and the Glomesh API, the Glomesh Gateway API, where you can say, for example, I want to route to something that lives in a cloud provider. So here we actually have a Lambda function that we're routing to, which means we can actually invoke this product page and everything that it provides via a Lambda function in this example. And so that when requests come and they match this product page, instead of going to the product page service, they'll actually go and hit a Lambda, which is all this configuration, and the security credentials would be provided through Glomesh specific configuration. So just to understand, architecturally speaking, how this actually looks from the user point of view, the users are going to supply a gateway class, gateway, and HTTP route objects. Additionally, they may provide destinations as well, destination CRDs, setting CRD, and there are additional config options that may be external to this routing configuration, like policy objects, which can be shared across gateways as well as within the mesh. So the user supplies these CRDs to the Glomesh control plane, The Glomesh control plane then distributes the translated configuration down to each Istio control plane running in each cluster. Those Istio control planes, which are supercharged with the Gloo features that are being ported over, will then go and configure the individual Envoy proxies with all the filters and configuration necessary to achieve this multi-cluster gateway setup. So just for an example, now that this is configured, a user comes and makes an HTTP request to the gateway in cluster 1 on product page. That gets routed to the local product page, just like in today's world. But what happens when the user sends a request to an ingress in a different cluster? So what we've done here is we've created a gateway data plane that spans across clusters. It's a logical data plane, a logical ingress into our service mesh that abstracts away the requirement to think about cluster. This is particularly useful when we have copies of clusters that are sitting. We have multiple instances of a cluster or an application, a single application that is distributed across clusters. So we don't want to have to worry about which ingress, which gateway a client is talking to, because we know the appropriate destination cluster for that. And we don't want the client to have to know which cluster to talk to in order to talk to that service. So what you'll see here is that under the hood, Glomesh will configure each proxy or ensure the proxy configuration, the Istio configuration, in each cluster is lined up so that we know how to send requests to the appropriate cluster. This allows us to have a multi-cluster data plane that includes the gateway spanning all of our clusters. Additionally, one of the things that we bring to the table are advanced security features. This is one of the things that distinguishes an API gateway from just a simple ingress, is when you have advanced features like CORS, data loss prevention, WAF, external authentication services, JOT validation, rate limiting, etc. This is one of the most heavily utilized and requested features in Glomesh today, or in Gloo Edge, that Gloo Edge production users are making use of, and we've built out the system a lot. Our external auth implementation includes Boolean logic to allow more complex use cases. And what we see on the right here in this diagram is actually a series of security filters that are used to secure and ensure that all requests that make it into our upstreams or destinations are trusted and have been validated. So we have here a set of filters that can be enabled on the ingress. And you'll see here that the external auth and rate limiting filters talk to an externally implemented server. This is normally on the user to supply their own, but this is one of the things that Gloo provides. The enterprise version of Gloo provides out of the box, and the implementation of the external auth provides basic auth support, OAuth, API key, open policy agent can be used to authenticate requests. You can plug in an LDAP backend. You can also provide your own custom auth plugins or pass through auth to another server that's implemented by the user. The usefulness of this is that when clients make requests, first they are authenticated through the XDauth server, and then an identity is provided if the user is authenticated. Once the user is authenticated, we can then verify that this user identity is permitted through the rate limit, that they're not being rate limited. And if they are, we allow the request through and complete the communication. So now I'm going to hand it back over to Shane for a demo, who's going to demo these advanced features running in our multi-cluster setup.
So here we've got our two clusters installed. On the left here, you can see we've got our management cluster, and on the right, we've got a remote cluster. You can see that Istio is installed on both clusters. So we've got two different meshes installed on two different clusters. We've also got Glomesh installed, and the Istio book info app is split across both clusters. You can see product page is running here on the left and details is running here on the right. Now let's take a closer look at some of those YAMLs that Scott was just walking us through. So again, this is the Kubernetes Gateway API spec. And I just want to call your attention to a couple things in here. First of all, you'll see that we're running this on two different clusters. So this means that these ingress gateways are going to be deployed to both clusters once we apply these CRDs. Next, I just want to highlight that we're exposing port 8080 as a listener here. And finally, the routes that we're opening are going to be serving productpage.example.com and they'll be looking for the route specifically /product page, which will be forwarding to the service product page that runs in our management cluster, as well as /details, which will forward to the details service running in the remote cluster. Again, it's worth highlighting these two services run in two different clusters, even though we're configuring them all in the same place. So I'm going to apply that YAML now to the Glomesh management plane. What we should see here is two different ingress gateways being deployed here, one in each cluster. And we do. We see one coming up here, and we see one coming up here. So both of these meshes will be serving the endpoints that we just looked at in a HTTP route. Let's do some port forwarding so we can try them out. So I'm going to port forward here, port 8080 on this mesh ingress gateway that we just deployed using those CRDs. And then in the remote cluster, I'm going to forward, that's also running on 8080. I'm just going to port forward it to 8081 locally, just so that we can try both of them in parallel. And now I'm going to curl these services. So we're doing a curl on 8080 to the detail service. So we're going to be hitting this management cluster. And you can see we get a response here from the detail service, even though the detail service is running in cluster 2 and we hit the ingress in cluster 1. Similarly, if we change the port here, we can hit it on 8081. So we've hit the ingress in cluster 2, which will serve the request locally from the detail service that's found in the same cluster. So what else can we do with this YAML, this new API? Here's a little bit of an extension that we worked on earlier. So it's the exact same CRDs I just showed you. The only difference is down here at the bottom, we've added this filter section. Anyone who's familiar with our Gloo Edge API external auth config will recognize this because it's the exact same config. It's the same syntax. Anyone who's familiar with who's used that before. And specifically, if anyone's not familiar with it, we'll just walk through it real quick here. We're adding an authentication filter, and we have two different types here. That's what's interesting. So we're adding basic auth, so you can authenticate with the username user and the password, or you can authenticate with an API key of SoloCon demo key 1234. We're using this advanced Boolean expression logic that's currently found in Gloo Edge API Gateway today, where you can authenticate with either basic auth or the API key. So let's take a look at what that looks like when it's running. And now if we try to curl those requests again, you'll see now we're getting a 403 because we didn't provide any authentication. So once I start adding our API key, and here it's just as simple as adding the API key in a header called API key, you'll see that we're getting 200s. Similarly, if I add a bad API key that's not authenticated or authorized, you'll get a 403 again. And remember, we also added basic auth. Here's an example of that working. I run a basic auth. Now we're getting 200s again. We see the response we expect. We got a 200. Everything's great. So this is just a few features that we're working on in this new platform, and it's just to give you an idea of what's possible. But there's plenty more to come, and we're really excited to show it to you. So what we've just shown you is that you can have the best of both worlds. You get all of the incredibly powerful enterprise-grade features of Gloo Edge API Gateway running in a multi-edge, multi-cluster environment thanks to Glomesh. And remember, all of this is sitting on top of this newly supercharged Istio environment, which itself is sitting on top of Envoy. So you're getting a lot of power from all of those low-level tiers, but you only have to deal with the high-level config that goes into the management plane. Thanks for listening to our talk, and we'll now take any questions.